Like many computer systems that are managed through a web interface, Proxmox VE is supplied with a self-signed certificate. So when you try to connect to the server, your web browser is going to warn you that it can't validate the actual certificate. In other words, it can't determine if the server that you're connecting to is genuinely the server that you think that it is. Now, it might be tempting to ignore these sort of warnings, particularly for internal servers, but a better security approach to adopt is to only use signed certificates that your web browser trusts. This way, you're less likely to fall victim to a man-in-the-middle attack or to be redirected to a site that's got malware on it. But how do you configure Proxmox VE with a signed certificate? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, there are different ways to provide Proxmox VE with a signed certificate. I'm connected into a server at the moment, and if I go down to where it says System and then Certificates, you see at the top here we've got our manual method, and then below that we've got our dynamic method. Now, as much as I'd love to use a service like Let's Encrypt, for example, where I'd be able to dynamically obtain an actual certificate to get that automatically renewed before it expires and so on, the problem is it's not really a recommended practice when it comes to certificates, because the idea is you would use a public certificate authority for your public servers and an internal certificate authority for your internal servers. The reason being is that when it comes to public servers, everybody needs to know the IP address that you've got anyway. It doesn't really matter that that information's out there in the public domain. The problem with internal servers is you don't want that information out in the public domain, because if an actual hacker can get a foothold in your network and that information is already out there on public view, it makes their life a lot easier to get deeper into your network and cause more problems. So that's why the recommended strategy is have a public CA for your public servers and have an internal CA for your internal servers. In which case, we're going to have to follow this manual approach. And at the moment, all we've got is this self-signed certificate here that's already been provided. There isn't an option to create a certificate request, just an option to click the upload button there and upload a certificate. Although there is an alternate option, and that's to do it through the command line. You can actually upload certificates through the command line as well. Now, what we're going to be doing is actually following both approaches, because this is a standalone server. And then what I've got here is an actual cluster. Now, when it comes to a standalone server, I can create a certificate for it and then just upload it through that GUI. But when it comes to the actual cluster that I've got, it's actually easy to do it through the command line, because information gets replicated around. If I upload all of the certificates for all my servers to node 1, for example, it'll copy those out to node 2 and to node 3. So it does make life a bit easier. So how you obtain that actual certificate in the first place really depends on your circumstances, though. I mean, you could have a NAS, for example, that's got a certificate authority. You could be using a firewall like pfSense. Even that has an actual service to provide a CA server that you can create certificates from. So it really depends on your circumstances. Now, in my case, what I'm going to be doing is to use OpenSSL. I'll create the actual certificates on that actual server, and then it's just a case of going through the process of uploading them to the actual Proxmox servers here. Now, I'm going to be using OpenSSL as my certificate authority server. If you're not already familiar with that, then I do have an actual video that covers how to create your own CA server using OpenSSL, and how do you actually use that to create signed certificates for your servers. On the other hand, if you're going to be using a completely different CA server yourself, then feel free to skip ahead, because what we're going to be doing here is to create a private key for our standalone server, plus a certificate server request, as well as an actual signed certificate. Now, I do need to do the same for the other 3 servers in my cluster, but I'm not going to go over that on camera because the process is just identical. So I'm logged into my actual CA server. Now, I only actually power this on. It's only available and accessible on the network when I'm actually using it. That's just for security reasons. So the first thing I need to do now that I'm logged in is to actually change to my CA folder. And then what we're going to do is to create an actual private key. So I'll just paste this command in, where we're going to create a key with 2048 bits. We don't want a passphrase on it. because if you've got a passphrase on a private key, you have to actually enter the passphrase every time that key gets used. Not surprisingly, Proxmox, if you look in their documentation, they don't recommend using one because it isn't something you do for a web server. So I'm just going to hit return. That creates my private key. I'm then going to create a configuration file, because this is going to make life a bit easier when it comes to actually creating the commands. So hit return to create that file, and I'm going to paste in all the information that we need for this certificate. So the key things to point out, I mean, I do cover this in more depth in the video about OpenSSL as a CA server, but key things to point out, we want 2048 bits. I'm referencing here to my fully qualified domain name, which is how I connect to this through the actual web browser. I also have to put in a subject alternate name. Now, the reason you need that is more to do with Google Chrome browsers. The idea is you can connect to a server using different FQDNs. You can connect it using IP addresses. I mean, if you reference over here, there's a lot of alternate names that Proxmox has got over here, for instance. But in my case, I'm just going to connect to this server using its FQDN. But even still, I still need to reference that as a subject alternate name. Otherwise, Google Chrome browsers will not accept that certificate. So now that I've got the details in there, I'll save that config file. Next thing we're going to do is to actually create the certificate server request. So basically we're referencing a private key that we created plus the actual config file that's got all the information. And then what we're going to do is we're going to, in one command, we're actually going to then get OpenSSL to create a certificate and actually sign it with all this information that we've created here. So I'm going to hit paste, hit return. I need to put in my password for my actual private key here. I need to say yes that I want to sign the certificate, and yes, I want to commit that to the database. One thing I'll point out incidentally is I did have to refer back to the config file before. As I've explained in this other video, it's a feature, if you will, where even though the CSR file contains information about the subject alternate name, OpenSSL will not put that in the certificate unless I specifically tell it to here. So that's what that bit there's for. I've got to tell it to put that information in. So now we've actually created our certificate. If we do cert, I've now got an actual certificate called pv-solo.crt, which is a signed certificate from this certificate authority. If I use that on this server, all my web browsers will trust it because all of my web browsers trust this certificate authority server. Well, now that I've created all of my keys and certificates for the servers, the next thing I need to do is to actually transfer these over off of the actual root certificate authority server, so I can actually then upload them to the actual Proxmox servers themselves. There are different ways you can do this. Windows being the more common operating system is what I'm using at the moment, and I've opened up a session using WinSCP, so I can connect into the root server and then just basically copy the actual files across to my computer, and then from that computer I can upload them to the Proxmox servers. So as you can see, I'm logged in and we're into the home folder of the use that I've got on that root server. So I need to go into the CA folder, go into the certs folder. There's all of my actual certificates that I created. So I'm going to copy those across. I'm then going to go up a level because I also want the actual private keys. So I'm going to now go into the private folder, and I'm going to select all of those private keys that I created to copy those across. And now that I've actually got access to those files on the local computer, so then I'll be able to transfer them across to the actual servers. Now when it comes to a standalone server like this one, installing a signed certificate through the GUI is a very straightforward process. You log into the server, connect to that, then go to System and then Certificates, and then you click on the option here, Upload Custom Certificate. Now we've got choices where we can either paste the information into the fields, or we can just upload from actual files. So since I've actually transferred some files across and they're actually on this Windows computer, I'm just going to point them to the actual file itself. So I'm going to click on the button here for the private key, which is what I want to upload. Click on From File, point to my Documents folder, go to Certs, and then I want that actual key there. That's the one for this specific server. So I'll double click on that, give it a while, and it'll import that actual key from the file. We then go to the actual certificate itself. So I'm going to click on From File, and then I need the CRT file in my case. So that's the one I want specifically for this server. So I'll double click on that. And again, it's going to upload that file and it'll put the information into the field. Now, one thing to bear in mind, this is talking about a certificate chain. I'm not dealing with an intermediary certificate, so I don't have to actually worry about that. My browsers will trust any certificate signed by my root CA server, which means this certificate here will be trusted by my web browsers. It gets a bit more complicated if you're using an intermediary server, and that's really beyond the scope of this video. But that's something to bear in mind, as if you're using an intermediary certificate, you don't just want the actual server certificate, you've got to combine the actual intermediary certificate in with the actual server certificate itself. Anyway, I've got my private key here and I've got my actual server certificate here, so I'm going to click on the upload button. So it's going to install that, and as you can see, it's saying that it's going to basically restart the actual web server to use this new certificate. So it's telling me to please reload the web interface. It automatically does that anyway. Now you can see it's complaining at the moment still that it doesn't trust this certificate, but I'm going to click on the refresh button. Now I get mixed results here. Sometimes it works, sometimes it doesn't. Might be to do with Brave, I don't know. But I'm just going to close the actual web browser. I'm going to open it back up again. It should open up the last page that I was connected to. And you can see this time round, I'm actually getting the locked padlock. So it does actually trust this certificate. So that's a better strategy or a better solution than using an actual self-signed certificate, because there's my signed certificate down here. I mean, I can get details of it by clicking on View Certificate. It tells me who created it and tells me how long it's going to go for, and so on, what date of expiry it is. There's my subject alternative name over here. But we've still got the actual self-signed certificate to fall back to if we have to, something to bear in mind. It's just that strange behavior. As I say, I don't know whether it's specific to Brave, where sometimes I have to actually close the web browser and open it back up again to get this to work. But the key point is we're not getting that warning that the connection's not secure. We did have an encrypted session to the server, bear that in mind. It was still a safe, secure connection in that respect. The only trouble is when you're using a self-signed certificate, you don't necessarily know if you were connecting to the legitimate server. You don't know if there's another server in between your computer and the actual server, or whether the server that you connect to is something completely different. So it's by having that closed padlock, it gives you that assurance that you are connecting to a server that you trust is the correct server, because your computer, or more specifically the web browser, trusts the certificate that that server is presenting, because it trusts your root certificate authority. So that's how you actually install a signed certificate on a standalone server like this one using the GUI. Now when it comes to installing signed certificates on a cluster of servers, I'm going to take a slightly different approach. So what I've done is I've actually logged into server number 1. I've logged in as root using WinSCP, because what I want to do is to actually transfer my files across from my local computer over to this server, and then get that server to replicate them out to the other servers. So if you look over here on the right hand side, as I say, we're logged in as root. If I go up a folder, go to the Etsy folder, scroll down to PVE, and then to nodes, you'll see there's a folder for each of the 3 servers that I've got. If I go into node 1, for instance, we've got a private key and we've got a certificate. So the intention is really to replace these files with my own signed certificates. I'm actually going to take backups of these ones first. But what it'll mean is by transferring them across and then restarting the web server, they'll actually start using the signed certificates instead of these actual self-signed certificates. And because I can do this by just connecting into one server, saves me having to go around each server individually. So the first thing I need to do is to actually rename these actual keys and certificates so that they line up. So the key needs to be pve-ssl.key, the actual certificates pe-ssl.pem, and I'll need to create a separate folder for each of the actual nodes that I've got, because you can't have, two files with the same name in the same folder. So I'm going to shuffle things around over on the local computer so that we can then start transferring things across. Well, I've now sorted out the keys and certificates on the actual local computer. So I've got a separate folder, one for node 1, one for node 2, and one for node 3. So if we go into there, for example, we've now got a pve-ssl.key file and a pve-ssl.pem file. If I go over to the actual server, I've also renamed the existing files. I've put on a .old extension because basically I want to have a backup of the existing files. I don't want to just overwrite them. I want to be able to put new ones in, but I want that option to fall back to if I need to. So what I need to do now is to actually copy these 3 folders across, and then that'll copy our signed certificates over. So if we go over to here, you can see we've now got a key file and a PEM file for node 1. Same for node 2. And the same for node 3. But the thing is, we actually need to get the actual web server restarted for all of this to take effect. So to restart the service, I've logged in to the actual server 1 as root. And what I'm going to do now is run a command systemctl restart PVE proxy. So we'll get that to restart, and then once it's back up and running, we should be able to connect in to the actual web server, but using that signed certificate. So if we go over to our web browser here, if I do a refresh, just check if I'm using the right protocol here. Then you can see how we've got a padlock on it now. So I'll log in as root. No, I do not want to be saving my passwords. So there you go. We've now got an actual padlock on this actual connection here. So we now know it is a fully secure connection because the web browser trusts the actual certificate because it's been signed by our root certificate authority. Now I'm going to have to go around these other 2 servers and restart their services next. Well, I've now restarted the service on each of these 3 servers. So I've got node 1, you see, closed padlock. Node 2, closed padlock. Node 3, closed padlock. The reason I actually want to put in actual signed certificates on all 3 servers is because I can manage the cluster through any of these actual nodes. So whether it's maintenance, faults, I want that ability to connect to any one of these servers for management reasons, which means I need all 3 of them to have these signed certificates. If I go back to WinSCP, what I've been doing is I've been connecting into the actual servers themselves just to show you how they do this replication. So as you can see on server 1, I made some backup files and then I copied across new files. If I go over to server 2, it's exactly the same. Go over to server 3, it's exactly the same. So that to me is a bit of an easier approach really, where I just have to update one specific server. That gets replicated out to the rest. So it's a pretty simple process, I must admit. I mean, using the certificate authority server, the OpenSSL server that I've got, and create all of these actual certificates and private keys all in one batch. Then it's just a matter of renaming them and getting them across to the actual server. But once it's done, it's pretty straightforward. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released. although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.